Hey everyone, welcome back. Today I'm gonna work on a sensor, digital sensor that is LIS3DHTR. To have a knowledge about this sensor, to have a look about this sensor, so what we have to do is to visit the website that is controleverything.com, and here we have to search out for this sensor as you can see on my screen. Now let's have a look over the sensor. As you can see, it's a 3-axis accelerometer. So it will have a digital output motion sensor, as you can see, free fall detection, 3-axis accelerometer, 6D, 4D orientation detection. These are some of its features which you would like to see. You can purchase this sensor. Well, I'm gonna interface the sensor LIS3DHTR 3-axis accelerometer with a Raspberry Pi and a Java code. So let's go to resource tab, and here comes the Java code sample. Now you can download the Java code sample as a zip file from this very link on this very site. Now you can have the choice of downloading the code from GitHub repository that is Control Everything community. So by now we need some hardware so that we can make the working of this sensor. Let's have a look over that also. This here is our sensor LIS3DHTR, and this here is our Raspberry Pi. Now these are the GPI pins of the Raspberry Pi. Now we want to make a connection among the sensor and the Raspberry Pi, and here comes an I2C shield. Now this is available on the website controleverything.com, and we want to make a connection. So gently place over the I2C shield over the GPI pins of the Raspberry Pi. Now this here is our connecting cable. Make the connection among the sensor and the connecting cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly this fundamental rule has to be applied for the I2C shield also. Now we want to make the Raspberry Pi on, so a micro USB cable comes into the picture, and just insert it over the power jack and it will light it up. Now the last part is to make an internet connection. So for that we have two ways. First of all, this is an Ethernet cable. Now gently insert it over the power jack. The second way is this, a wireless Wi-Fi nano adapter. Now it can make your work a lot easier. So we are done with the connections part. Next we require our code so that we can interface it with our sensor and the Raspberry Pi. Let's have a look over it. Now to interface the sensor with the Java code, let's dig up the website that is github.com, and here we have to search for the repository that is Control Everything community. So get over it, and here we have to look out for the sensor that is LIS3DHTR, and here is our required accelerometer sensor. Now this is the code, Java code we are looking forward to explore, but before that let's have a look over the instructions we need to follow to pursue this code. And it says that we have to download and install Pi4J library on the Raspberry Pi, and the steps to install Pi4J are being provided on this link. So why not open this link to have a better view for this installation. As you can see, information regarding installation, commands, offline upgradation, uninstallation, everything is there. So you need to follow this. Now this is the command to compile the Java code, and this to run the Java code. Note it down. Now let's have a look over the code, which I would explain. As it says that .java is the extension file, and we need to follow up .java, right? Now we have to import some of the files, some of the libraries, as you can notice, and we have created a class named LIS3DHTR. Now we got the address of the sensor bus.getDevice, it's 0x18. Now comes the writing section part, which says that we have to select control register 1, that is 0x20, and we have to send a command on this register which goes for XYZ axis, enabling power on mode data rate output to be 10 Hz, and the command for that is here, as you can see. Now we have to select the control register 1 having address 23, and we have to send a command there that comprises full scale range plus minus 2G continuous update, and 0x06 is that, and the device.write command is there. Now we are done with this, as we have a sleep function to make it available for the sensor to acknowledge the commands. Now after that, response of the sensor needs to be taken care of, and this is called the reading part, where we have read 6 bytes of data from the register, as you can see 28. Now it's acceleration data in XYZ axis, and here comes the conversion of the data which is taking place according to the details being provided in the datasheet of LIS3DHTR. So we are done with the conversion part, writing part, reading part. So why not have a data output on the screen in the form of acceleration for X, Y and Z axis. As you can see, percentage %d raw values will be displayed. So now what do we require is to show the working. So why not have it? And here comes the interesting part, which is to show the practical working of this code along with the sensor. So copy this code first of all. Now open up the terminal for the Raspberry Pi. We have just connected through internet, as you can see. Now we create a new file, LIS3DHTR.java. So this the instruction, and we will paste the entire code we have just copied, and we will save the code, and this is the command to compile it. And here goes the compilation step. It's done. Now this is to run the code as we have noted down, and here we go. The acceleration in X, Y, Z axis are there. As you can see, the values are almost constant, which says that the stable is not in motion. It's the sensor is stable. Now when I try to move it, you can see the change in the values for acceleration in X, Y and Z axis, and it's being continuously moved, which changes are being displayed continuously on the serial monitor or the screen of the Raspberry Pi. Now this is how the Java code works along with the sensor. Now what do we require is to see the benefits and the applications for this sensor. So let's have it. Now the LIS3DHTR is an ultra low power high performance 3-axis linear accelerometer belonging to the nano family with digital I2C SPI serial interface standard output. Now the device features ultra low power operational modes that allow advanced power saving and smart embedded functions. This sensor has dynamically user selectable full scales of ±2G up to 16G, and it's capable of measuring accelerations with output data rates from 1 Hz to 5 kHz. Now various applications uses this sensor, which are motion activated functions, free fall detection, double click recognition, pedometer, display orientation, gaming and virtual reality, input devices, vibrational monitoring and compensation, and a lot more. Now you can purchase the sensor from the website controleverything.com, as you can see, and you can also have the code from the resource tab. You can download it from this site. You can also have the code from GitHub repository, and the repository is Control Everything Community. Now you can have the queries on controleverything.com. You can contact there, and you can have your comments posted on the community page. Also, for relevant blogs and articles, you can reach us on instructables.com, and to have more video tutorials, you can subscribe our YouTube channel. In the end, I just want to make it clear that you understood everything, and in case of any issue regarding any part of this video, you can contact me on controleverything.com. I hope you enjoyed this video and yourself have a good one. Thanks a lot for watching.